Question 1. Stakeholder feedback indicates a desire for comprehensive, real-time visibility into all aspects of the operational environment, including granular performance metrics and detailed transaction logs. As an IBM Cognos real-time monitoring developer, which approach best balances the demand for detailed data with the need for system stability and security. Option A. Prioritize the collection of all transaction logs and detailed performance data, assuming that the underlying infrastructure can handle the load, and implement basic access controls for the monitoring data. Option B. Implement a comprehensive monitoring configuration from the outset, capturing all available metrics at the highest possible granularity, and address any performance issues that arise subsequently. Option C. Develop a phased monitoring strategy, starting with essential metrics and a moderate granularity, then iteratively increasing data collection and refining configurations based on observed system performance and stakeholder feedback. Option D. Focus on collecting only high-level aggregate metrics to minimize system overhead, and rely on separate, ad hoc diagnostic tools for detailed analysis when issues are suspected. Correct answer is B. Implement a comprehensive monitoring configuration from the outset, capturing all available metrics at the highest possible granularity, and address any performance issues that arise subsequently. Explanation. This scenario is professionally challenging because it requires balancing the need for real-time data visibility with the potential for performance degradation and the security implications of exposing sensitive operational metrics. The developer must make a judgment call on the granularity and frequency of data collection, which directly impacts the system's responsiveness and the integrity of the monitoring process. Careful consideration of the IBM Cognos real-time monitoring developer exam scope, which implicitly covers best practices in performance, security, and data management within the context of IBM's monitoring solutions, is paramount. The correct approach represents best professional practice because it prioritizes a phased implementation and iterative refinement based on actual performance metrics and stakeholder needs. This aligns with general software development best practices and the implicit requirements of a professional developer to deliver robust and efficient solutions. Specifically, it acknowledges that real-time monitoring is a continuous process of tuning and optimization, not a one-time configuration. By starting with a reasonable baseline and then adjusting based on observed behavior and feedback, the developer ensures that the monitoring solution enhances, rather than hinders, the operational environment. This approach minimizes risk and maximizes the value derived from the monitoring system. An incorrect approach that focuses solely on maximizing data collection without considering performance implications is professionally unacceptable. This would likely lead to system slowdowns, increased resource consumption, and potentially missed critical events due to system overload. This failure to consider performance directly contravenes the implicit professional responsibility to deliver solutions that are both functional and efficient. Another incorrect approach that involves implementing monitoring without clear objectives or stakeholder buy-in is also professionally flawed. This leads to the collection of irrelevant data, wasted resources, and a lack of actionable insights. It demonstrates a failure to understand the business context and the purpose of the monitoring solution, which is a significant ethical and professional lapse. A third incorrect approach that neglects security considerations when defining what data to monitor and how it is accessed is highly problematic. Exposing sensitive operational data without proper access controls or anonymization can lead to security breaches and compliance violations, representing a severe professional and ethical failure. The professional reasoning process for similar situations should involve a thorough understanding of the business requirements, a risk assessment of different monitoring strategies, and a commitment to iterative development and testing. Developers should engage with stakeholders to define clear objectives, establish performance benchmarks, and implement robust security measures. A phased rollout, coupled with continuous monitoring of the monitoring system itself, is crucial for ensuring its effectiveness and minimizing negative impacts. Question 2. Implementation of a robust error handling strategy in IBM Cognos real-time monitoring for ingested data that exhibits anomalies. Considering the need for both operational continuity and data integrity, what is the most professionally sound approach? Option A. Implement a complex statistical model to attempt real-time correction of all suspect data before ingestion. Option B. Quarantine suspect data for manual review and correction, logging all such instances for audit purposes. Option C. Log the anomaly as an error and continue processing the suspect data without further intervention. Option D. Automatically discard any data record identified as suspect to maintain the speed of real-time processing. The correct answer is B. Quarantine suspect data for manual review and correction, logging all such instances for audit purposes. Explanation. This scenario presents a professional challenge in ensuring data integrity and compliance within an IBM Cognos real-time monitoring (RTM) environment. The developer must balance the need for efficient data processing with the regulatory requirements for data accuracy and auditability. The core challenge lies in selecting an appropriate method for handling data discrepancies that arise during real-time ingestion, ensuring that the chosen method aligns with the principles of data governance and any applicable regulatory frameworks relevant to IBM Cognos RTM development, which in the context of this exam implies adherence to general best practices for data management and system integrity. The correct approach represents best professional practice because it prioritizes data accuracy and provides a clear audit trail. By implementing a mechanism to flag and quarantine suspect data for manual review, the developer ensures that potentially erroneous information does not corrupt downstream analysis or reporting. This aligns with the professional responsibility to maintain the integrity of the data being monitored and reported, which is crucial for informed decision-making and regulatory compliance. This method allows for investigation and correction without compromising the ongoing real-time data flow. An incorrect approach that involves automatically discarding suspect data without logging or review is professionally unacceptable. This failure represents a significant regulatory and ethical lapse. It directly violates the principle of data integrity by allowing potentially critical information to be lost. The data being monitored is subject to regulatory oversight, e.g., financial, healthcare. Discarding data without a trace could lead to noncompliance, fines, and reputational damage. It also hinders effective troubleshooting and system improvement, as the root cause of the data discrepancies remains unaddressed. Another incorrect approach, which is to simply log the error and continue processing without any quarantine or review mechanism, is also professionally deficient. While it acknowledges an issue, it fails to address the potential impact of the suspect data on subsequent analysis and reporting. This can lead to inaccurate insights and decisions based on flawed data, which is a breach of professional duty to provide reliable information. It also misses the opportunity to identify systemic issues causing the data anomalies. A professional decision-making process for similar situations should involve a thorough understanding of the data's criticality, the potential impact of inaccuracies, and any relevant compliance obligations. The developer should first identify the nature and frequency of data discrepancies. Then, they should evaluate potential solutions based on their ability to maintain data integrity, provide auditability, and minimize disruption to real-time operations. Prioritizing solutions that allow for investigation and correction while ensuring a robust audit trail is paramount. This systematic approach ensures that technical decisions are aligned with professional responsibilities and regulatory expectations. Question 3. The evaluation methodology shows a developer implementing IBM Cognos real-time monitoring for a financial services application. The primary goal is to monitor transaction volumes and system performance in real time. Considering the sensitive nature of financial data, which of the following approaches best balances the monitoring requirements with regulatory compliance and data privacy best practices? Option A. Focus on capturing detailed transaction logs for forensic analysis, assuming that any regulatory concerns can be addressed by implementing encryption at rest for the monitoring database. Option B. Prioritize real-time alerts for any transaction exceeding a predefined threshold, without explicit consideration for the specific data elements being monitored or their privacy implications. Option C. Design the monitoring solution to collect only aggregated metrics and anonymized transaction data, ensuring that no personally identifiable financial information is directly stored or processed by the monitoring tools. Option D. Implement comprehensive data collection, capturing all transaction details and customer identifiers, and rely on robust access controls within the monitoring system to protect sensitive information. The correct answer is D. Implement comprehensive data collection, capturing all transaction details and customer identifiers, and rely on robust access controls within the monitoring system to protect sensitive information. Explanation. The evaluation methodology shows a scenario where a developer is tasked with implementing real-time monitoring for a critical financial system. The challenge lies in ensuring the monitoring solution not only meets performance and functional requirements, but also adheres to stringent data privacy regulations. Specifically, the developer must consider how sensitive financial data is handled, stored, and accessed by the monitoring tools. The professional challenge is to balance the need for comprehensive monitoring with the legal and ethical obligations to protect customer data. This requires a deep understanding of both the technical capabilities of IBM Cognos real-time monitoring and the relevant regulatory landscape. The correct approach involves designing the monitoring solution with data minimization and anonymization techniques at its core. This aligns with the principles of data protection by design and by default, which are fundamental to many data privacy regulations. By only collecting and processing the minimum data necessary for effective monitoring, and by anonymizing or pseudonymizing sensitive information where possible, the solution reduces the risk of data breaches and noncompliance. This proactive approach demonstrates a commitment to regulatory adherence and ethical data stewardship, which is best professional practice. An incorrect approach that focuses solely on capturing all available data for maximum visibility without considering privacy implications would be a significant regulatory failure. This could lead to the unauthorized collection and potential exposure of sensitive financial information, violating data privacy laws. Another incorrect approach might be to implement monitoring without proper access controls, allowing unauthorized personnel to view sensitive data, which is a direct breach of security and privacy protocols. A third incorrect approach could be to store raw, unencrypted sensitive data within the monitoring system, making it vulnerable to breaches and non-compliant with data security mandates. Professionals should employ a risk-based decision-making framework. This involves identifying potential regulatory and ethical risks associated with each design choice, evaluating the likelihood and impact of these risks, and implementing controls to mitigate them. The process should include consulting with legal and compliance teams early in the development lifecycle to ensure all regulatory requirements are understood and addressed. Prioritizing data privacy and security from the outset, rather than as an afterthought, is crucial for building trust and ensuring long-term compliance. Question 4. The evaluation methodology shows that IBM Cognos real-time monitoring developers must implement effective data lifecycle management, considering the need to balance historical data accessibility for analysis with storage efficiency and system performance. Which data retention strategy best aligns with professional best practices for a critical performance metrics dataset? Option A. Delete all historical performance metric data after a fixed, short retention period to minimize storage costs and maximize system performance. Option B. Retain all historical performance metric data indefinitely in the primary high-performance storage to ensure immediate access to all data points. Option C. Implement a tiered data retention policy where data is moved to progressively less expensive and accessible storage as it ages, while ensuring compliance with defined retention periods. Option D. Rely on manual processes to periodically review and archive, or delete performance metric data based on ad hoc requests. The correct answer is C. Implement a tiered data retention policy where data is moved to progressively less expensive and accessible storage as it ages, while ensuring compliance with defined retention periods. Explanation. The evaluation methodology shows that IBM Cognos real-time monitoring, TRM, developers must ensure data integrity and auditability within the monitoring solutions they build. This scenario presents a challenge where a developer needs to implement a data retention policy for critical performance metrics. The challenge lies in balancing the need for historical data for trend analysis and troubleshooting against storage costs and potential performance degradation of the monitoring system itself. Furthermore, regulatory compliance, though not explicitly stated as a specific jurisdiction in this prompt, generally requires that data relevant to system performance and security be retained for a defined period to support audits and investigations. The developer must select a strategy that is both technically sound and adheres to implicit best practices for data management and governance. The correct approach involves a phased data retention strategy. This means that data is not simply deleted after a fixed period, but is instead moved to progressively less accessible and less expensive storage tiers as it ages. For example, recent, frequently accessed data might remain in high-performance storage, while older data is archived to slower, cheaper storage. This approach represents best professional practice because it directly addresses the core challenge, optimizing resource utilization while maintaining access to necessary historical data. It aligns with principles of efficient system design and data lifecycle management, which are crucial for long-term operational stability and cost-effectiveness. From a compliance perspective, it ensures that data remains available for audit purposes for the required duration, even if it's not immediately accessible. An incorrect approach would be to implement a simple, fixed-duration deletion policy for all data. This fails to acknowledge the varying needs for historical data. For instance, critical incident investigations might require data that has already been purged under such a policy, leading to a significant compliance and operational failure. Ethically, it could be seen as a failure to adequately safeguard information necessary for accountability. Another incorrect approach would be to retain all data indefinitely without any archival or tiered storage. While this might seem to ensure data availability, it is professionally unsound due to the exorbitant storage costs and the significant performance impact on the TRM system. This can lead to system instability, increased latency in monitoring alerts, and ultimately, a failure to meet the primary objective of real-time monitoring. It also creates an unmanageable data sprawl, making it difficult to extract meaningful insights. A third incorrect approach might be to rely solely on manual data management for retention. This is highly prone to human error, inconsistencies, and delays, which can lead to accidental data loss or non-compliance with retention policies. It also diverts valuable developer time from core development tasks to administrative overhead, which is an inefficient use of resources. The professional decision-making process for similar situations should involve a thorough understanding of the data's lifecycle, its access frequency, its criticality for business operations and compliance, and the associated storage and performance implications. This requires collaboration with stakeholders to define clear data retention requirements, followed by the design and implementation of a robust, automated, and tiered data management strategy that balances cost, performance, and accessibility. Question 5. The audit findings indicate that the IBM Cognos real-time monitoring system's event logging is insufficient to provide a complete and verifiable audit trail for critical operational changes, potentially impacting compliance with data integrity regulations. What is the most appropriate approach to address this audit finding? Option A. Implement a configurable logging framework that captures detailed information for critical events, such as configuration modifications and security alerts, while employing aggregated logging for high-frequency, less critical events, ensuring the logging configuration itself is auditable. Option B. Develop a custom logging solution that captures only a subset of events deemed important at the time of development, without provisions for future configuration or auditing of the logging mechanism. Option C. Disable logging for all non-essential events to optimize system performance and reduce storage requirements, thereby addressing the performance aspect of the audit. Option D. Increase the logging verbosity for all system events to ensure maximum data capture, regardless of event criticality or potential performance impact. The correct answer is A. Implement a configurable logging framework that captures detailed information for critical events, such as configuration modifications and security alerts, while employing aggregated logging for high-frequency, less critical events, ensuring the logging configuration itself is auditable. Explanation. Scenario analysis. This scenario presents a common implementation challenge in real-time monitoring, ensuring data integrity and auditability while meeting performance demands. The challenge lies in balancing the need for comprehensive logging to satisfy audit requirements with the potential performance impact of excessive logging, which could degrade the real-time monitoring system's responsiveness and accuracy. The auditor's finding highlights a potential gap in the system's ability to provide a verifiable trail of critical events, which is crucial for compliance and security. The developer must implement a solution that is both effective in capturing necessary data and efficient enough not to compromise the system's core function. Correct approach analysis. The correct approach involves implementing a targeted and configurable logging strategy. This means identifying specific critical events that require detailed logging for audit purposes, such as configuration changes, security-related alerts, and significant data threshold breaches. These events should be logged with sufficient detail to reconstruct the context and actions taken. For less critical or high-frequency events, a summary or aggregated logging approach can be employed to reduce overhead. Crucially, the logging configuration should be dynamic and auditable itself, allowing for adjustments based on evolving compliance needs or performance monitoring. This approach aligns with best practices for system design and operational management, ensuring that auditability is achieved without undue performance penalties. It demonstrates a proactive understanding of both functional and non-functional requirements, including regulatory compliance. Incorrect approaches analysis. Implementing comprehensive, verbose logging for all events, regardless of criticality, is an incorrect approach. This would likely overwhelm the monitoring system, leading to performance degradation, increased storage costs, and making it difficult to find relevant audit information amidst a sea of data. From a regulatory perspective, while seemingly thorough, it fails to demonstrate efficient resource management and could be seen as a compliance check-the-box exercise rather than a well-designed solution. Disabling logging for certain types of events to improve performance is also an incorrect approach. This directly contravenes the audit finding and creates a significant regulatory and ethical failure. By omitting logs for potentially critical events, the system loses its ability to provide an auditable trail, which is a fundamental requirement for many compliance frameworks. This could lead to severe penalties if an incident occurs and the necessary evidence is unavailable. Implementing a logging solution that is not configurable or auditable is another incorrect approach. This creates a rigid system that cannot adapt to changing regulatory requirements or operational needs. If the auditor later requests specific types of data that were not initially logged, or if the logging volume becomes problematic, the system cannot be easily adjusted. This lack of flexibility is a professional failing, as it does not anticipate future needs and creates a maintenance burden. Professional reasoning. Professionals faced with such a scenario should first thoroughly understand the specific audit requirements and the underlying regulatory framework. This involves identifying which events are truly critical for audit purposes. Next, they should assess the performance implications of different logging strategies, using system monitoring tools and performance testing. The decision-making process should prioritize a solution that achieves the required auditability with the least impact on system performance and resource utilization. This involves a trade-off analysis, where the cost of logging, performance, storage is weighed against the benefit, auditability, compliance. The chosen solution should be documented, and its configuration should be version-controlled and auditable to ensure transparency and accountability. Question 6. Investigation of the most effective strategy for protecting sensitive customer information within an IBM Cognos real-time monitoring environment, considering the need for operational visibility and compliance with data protection regulations, involves evaluating different data handling methodologies, which approach best balances real-time monitoring needs with the imperative of safeguarding personal data. Option A. Monitoring only non-sensitive operational metrics and excluding any customer-specific data from the Cognos RTM system entirely. Option B. Storing all raw, sensitive customer data within Cognos RTM and applying complex, post-processing anonymization algorithms only when data is queried for dashboard display. Option C. Displaying raw, sensitive customer data on Cognos RTM dashboards and relying solely on user access controls to restrict visibility to authorized personnel. Option D. Implementing robust data masking and aggregation techniques at the data source or during data ingestion into Cognos RTM, ensuring that only anonymized or summarized data is presented on monitoring dashboards. The correct answer is D. Implementing robust data masking and aggregation techniques at the data source or during data ingestion into Cognos RTM, ensuring that only anonymized or summarized data is presented on monitoring dashboards. Explanation. This scenario presents a professional challenge in ensuring data integrity and compliance within an IBM Cognos real-time monitoring (RTM) environment, specifically concerning the handling of sensitive customer data. The core difficulty lies in balancing the need for real-time performance and comprehensive monitoring with the stringent requirements for data privacy and security, as mandated by relevant regulations. Professionals must navigate the complexities of data masking, aggregation, and access control to prevent unauthorized disclosure or misuse of sensitive information, while still providing actionable insights. The correct approach emphasizes a layered security strategy that prioritizes data minimization and anonymization at the source or during data ingestion into the RTM system. This aligns with the principle of privacy by design and privacy by default, which are fundamental tenets of data protection regulations. By implementing robust data masking techniques and aggregating data to a level where individual identification is impossible before it reaches the monitoring dashboards, organizations uphold their legal and ethical obligations to protect customer privacy. This proactive measure significantly reduces the risk of data breaches and ensures that the monitoring system itself does not become a vector for privacy violations. An incorrect approach that involves displaying raw, sensitive customer data directly on RTM dashboards, even with the intention of later filtering or restricting access, represents a significant regulatory and ethical failure. This method exposes sensitive information unnecessarily, increasing the risk of accidental disclosure or unauthorized access. It violates the principle of data minimization, as more data is collected and processed than is strictly required for the immediate monitoring task. Furthermore, relying solely on access controls after the data is exposed is a reactive measure that fails to prevent the initial exposure, which is a critical deficiency from a compliance perspective. Another incorrect approach, which focuses on implementing complex, post-processing data anonymization techniques after the data has been fully ingested and is being queried for dashboards, is also problematic. While it attempts to address privacy concerns, it is less effective than proactive measures. The data has already been stored in a more sensitive state, increasing the potential attack surface and the risk of compromise during storage or transit. This approach also adds significant processing overhead and complexity to the monitoring system, potentially impacting performance and making compliance auditing more challenging. The professional decision-making process for such situations should involve a thorough risk assessment, considering the sensitivity of the data being monitored and the potential impact of a data breach. This should be followed by a design phase that incorporates privacy and security considerations from the outset, adhering to the privacy by design principle. Implementing technical controls such as data masking, aggregation, and role-based access control at appropriate stages of the data lifecycle is crucial. Regular audits and reviews of the monitoring system's configuration and data handling practices are also essential to ensure ongoing compliance and to adapt to evolving regulatory requirements and threat landscapes. Question 7. What factors determine the most effective strategy for enriching real-time monitoring data within IBM Cognos real-time monitoring to ensure both performance and data integrity? Option A. The frequency of user requests for data analysis and the complexity of the user interface's data visualization components. Option B. Inherent processing capabilities of the IBM Cognos real-time monitoring event stream processing engine and the design of event streams for efficient data aggregation and filtering. Option C. The availability and speed of external databases that can be queried to supplement the real-time event data. Option D. The volume of raw data that can be efficiently transmitted to the application layer for subsequent processing and transformation. Correct answer is B. The inherent processing capabilities of the IBM Cognos real-time monitoring event stream processing engine and the design of event streams for efficient data aggregation and filtering. Explanation. Scenario analysis. This scenario presents a common challenge in real-time monitoring development, balancing the need for immediate data visibility with the potential for performance degradation and the ethical implications of data access. Developers must consider how their design choices impact system stability, resource utilization, and the security of sensitive information. The pressure to deliver a functional and performant monitoring solution quickly can lead to shortcuts that have long-term consequences, making careful judgment and adherence to best practices paramount. Correct approach analysis. The correct approach prioritizes efficient data retrieval and processing by leveraging the capabilities of IBM Cognos real-time monitoring's event stream processing engine. This involves designing event streams that are optimized for the specific data being monitored, utilizing appropriate aggregation and filtering techniques within the engine itself, and minimizing the need for external data lookups or complex transformations. This aligns with best professional practice by ensuring the monitoring solution is scalable, performant, and resource efficient. From a regulatory perspective, efficient processing can indirectly support compliance by reducing the likelihood of system outages that could disrupt critical operations or data logging, and by ensuring that data is processed in a timely manner as might be required by certain data governance policies. Incorrect approaches analysis. One incorrect approach involves performing extensive data transformations and aggregations in the application layer after data has been retrieved from the event streams. This is professionally unacceptable because it places an unnecessary burden on the application server, leading to slower response times, increased resource consumption, and potential bottlenecks. Ethically and regulatorily, this inefficiency could lead to delayed alerts or incomplete data, potentially violating service-level agreements or data integrity requirements. Another incorrect approach is to retrieve all raw data from the event streams and then filter and aggregate it in the user interface. This is a significant performance anti-pattern. It not only overloads the application server, but also transmits excessive data over the network, impacting overall system performance and user experience. From a regulatory standpoint, this approach could lead to data privacy breaches if sensitive information is unnecessarily exposed to the user interface layer, or it could violate data minimization principles if more data is processed than is strictly necessary for the monitoring task. A third incorrect approach is to rely heavily on frequent, unoptimized database queries to supplement real-time data. While some external data integration might be necessary, making this the primary method for data enrichment in a real-time monitoring context is inefficient. It introduces latency, increases the load on external databases, and can lead to data staleness. This can be a regulatory failure if the monitoring system is intended to provide a single source of truth for critical operational data, and its reliance on slow, external lookups compromises the accuracy and timeliness of that data. Professional reasoning. Professionals should approach real-time monitoring development by first understanding the specific data sources and the required insights. They should then design event streams and processing logic within IBM Cognos real-time monitoring to efficiently capture, filter, and aggregate data at the source. This involves selecting appropriate operators, defining efficient data models, and minimizing external dependencies. When external data is required, it should be integrated strategically, perhaps through scheduled updates or optimized lookups, rather than as a primary real-time data source. This iterative process of design, implementation, and performance testing, guided by an understanding of system capabilities and potential bottlenecks, ensures a robust, scalable, and compliant monitoring solution. Question 8. When evaluating the implementation of a new IBM Cognos real-time monitoring solution that requires access to sensitive customer transaction data, what is the most appropriate approach to ensure compliance with data privacy regulations and maintain data security? Option A. Begin the monitoring implementation immediately and address any potential data privacy concerns or security gaps as they arise during the operational phase. Option B. Proceed with monitoring all available customer transaction data to ensure no critical information is missed, relying on existing network security measures to protect the data. Option C. Implement comprehensive role-based access controls within Cognos real-time monitoring. Conduct a data minimization assessment to identify and collect only the essential data elements for effective monitoring, and establish a clear data governance policy for the handling of this sensitive information. Option D. Focus solely on encrypting the data at rest and in transit, assuming that access controls will be managed by the broader IT infrastructure without specific configuration for the monitoring tool. The correct answer is C. Implement comprehensive role-based access controls within Cognos real-time monitoring. Conduct a data minimization assessment to identify and collect only the essential data elements for effective monitoring, and establish a clear data governance policy for the handling of this sensitive information. Explanation. Scenario analysis. This scenario presents a professional challenge related to data privacy and security within the context of IBM Cognos real-time monitoring. The developer is tasked with implementing a new monitoring solution that requires access to sensitive customer data. The core challenge lies in balancing the need for effective monitoring with the imperative to protect this data from unauthorized access or misuse, adhering strictly to the regulatory framework relevant to the exam. This requires careful consideration of data handling policies, access controls, and the potential impact of the monitoring solution on data confidentiality and integrity. Correct approach analysis. The correct approach involves a proactive and compliant strategy. This means thoroughly understanding the data that will be monitored, identifying the minimum necessary data for effective monitoring, and implementing robust security measures. This includes leveraging Cognos real-time monitoring's built-in security features, such as role-based access control, to ensure only authorized personnel can view or interact with the monitored data. Furthermore, it necessitates a clear data governance policy that defines how the data will be collected, stored, and used, aligning with the principles of data minimization and purpose limitation. This approach directly addresses the regulatory requirements for data protection by design and by default, ensuring that privacy is considered from the outset of the development process. Incorrect approaches analysis. One incorrect approach would be to proceed with monitoring all available data without a thorough assessment of necessity. This violates the principle of data minimization, a cornerstone of many data protection regulations, as it collects and potentially exposes more data than is strictly required for the monitoring objective. This increases the risk of privacy breaches and noncompliance. Another incorrect approach is to rely solely on network-level security without implementing granular access controls within Cognos itself. While network security is important, it does not address the specific access needs of different users within the monitoring system. This could lead to unauthorized internal access to sensitive data, a failure to comply with regulations that mandate specific controls over data access based on roles and responsibilities. A third incorrect approach would be to assume that all data within the system is automatically protected by existing general IT policies without specific validation for the real-time monitoring context. Real-time monitoring often involves unique data flows and access patterns that may not be adequately covered by broader policies. This oversight can lead to gaps in security and compliance, as specific controls tailored to the monitoring solution are not implemented. Professional reasoning. Professionals should adopt a risk-based and compliance-driven approach. This involves 1. Understanding the data landscape and regulatory obligations. 2. Conducting a thorough data impact assessment for the proposed monitoring solution. 3. Designing and implementing security controls that are proportionate to the risks identified. 4. Regularly reviewing and updating security measures and policies to adapt to evolving threats and regulatory changes. This systematic process ensures that technical solutions are developed and deployed in a manner that upholds data privacy and security standards. Question 9. The audit findings indicate that sensitive customer personally identifiable information, PI, is being inadvertently exposed in real-time dashboards within IBM Cognos real-time monitoring due to an improperly configured data source connection. This exposure, if unaddressed, could violate data privacy regulations. What is the most appropriate immediate course of action? Option A. Proceed with the current dashboard configuration, assuming that the risk of actual PII misuse is low, and document the finding for future review during the next scheduled system update. Option B. Temporarily disable the specific real-time monitoring data source that is causing the PII exposure to prevent further unauthorized access, and await further instructions from senior management before proceeding with any remediation. Option C. Immediately revoke access to the affected dashboards and initiate a detailed investigation into the root cause of the data exposure, while simultaneously developing and implementing a secure data masking or anonymization strategy for the PII before re-enabling access. Option D. Implement a broad firewall rule to block all external access to the Cognos real-time monitoring server until the issue can be fully resolved, without specific analysis of the PII exposure. The correct answer is C. Immediately revoke access to the affected dashboards and initiate a detailed investigation into the root cause of the data exposure, while simultaneously developing and implementing a secure data masking or anonymization strategy for the PII before re-enabling access. Explanation. This scenario presents a professional challenge related to data governance and security within the context of IBM Cognos real-time monitoring, specifically concerning the handling of sensitive customer information. The core issue is balancing the need for real-time operational insights with the imperative to protect personally identifiable information, PI, as mandated by relevant data privacy regulations. The audit findings highlight a potential breach of these regulations, requiring immediate and informed action. The correct approach involves a thorough investigation to understand the scope of the issue, followed by the implementation of appropriate technical and procedural controls to mitigate the risk and ensure compliance. This aligns with best professional practices in data security and privacy, emphasizing a proactive and risk-averse stance. It demonstrates a commitment to upholding regulatory obligations, such as those that might be found in data protection laws, by ensuring that data is processed and stored securely and ethically. Incorrect approaches would fail to adequately address the regulatory and ethical implications. One incorrect approach might be to simply disable the monitoring without understanding the root cause or impact, which could lead to operational deficiencies and a failure to address the underlying security vulnerability. Another incorrect approach could be to ignore the findings, which is a direct violation of regulatory requirements and professional ethics, exposing the organization to significant legal and reputational damage. A third incorrect approach might be to implement a superficial fix without proper validation, which would not guarantee compliance and could leave the system vulnerable. Professionals should employ a structured decision-making process when faced with such audit findings. This involves 1. Understanding the specific regulatory requirements applicable to the data being monitored. 2. Conducting a comprehensive risk assessment to determine the potential impact of the identified issue. 3. Evaluating technical and procedural solutions to address the root cause and mitigate risks. 4. Implementing the chosen solution with proper testing and validation. 5. Documenting all actions taken and communicating findings to relevant stakeholders. This systematic approach ensures that decisions are informed, compliant, and ethically sound. Question 10. The audit findings indicate that the IBM Cognos real-time monitoring system is intermittently reporting inflated transaction volumes for a critical business process. As the developer responsible for this system, how should you address the immediate requests from operational managers for performance metrics, given the potential for data inaccuracy? Option A. Halt all data reporting to operational managers until the transaction volume issue is fully resolved and the data is confirmed to be 100% accurate. Option B. Provide a simplified, aggregated view of transaction volumes that smooths out the reported spikes, assuring managers that the overall trend is positive. Option C. Proactively inform the operational managers about the observed data discrepancies. Explain the potential causes being investigated and provide the most accurate data available with clear caveats regarding its current limitations. Option D. Continue to provide the raw, unvalidated transaction volume data as it is ingested by the system, without any commentary on potential anomalies, to avoid causing alarm. The correct answer is C. Proactively inform the operational managers about the observed data discrepancies, explain the potential causes being investigated, and provide the most accurate data available with clear caveats regarding its current limitations. Explanation. Scenario analysis. This scenario presents a professional challenge stemming from the inherent tension between the need for timely, actionable insights from real-time monitoring data and the imperative to ensure the integrity and accuracy of that data. Stakeholders, such as business analysts and operational managers, often have immediate demands for performance metrics. However, a developer responsible for IBM Cognos real-time monitoring must balance these demands with the technical realities of data ingestion, processing, and potential data quality issues. The challenge lies in managing stakeholder expectations while upholding data governance principles and avoiding the propagation of potentially misleading information. Careful judgment is required to determine when data is sufficiently validated for reporting versus when further investigation or refinement is necessary. Correct approach analysis. The correct approach, which involves proactively communicating potential data discrepancies to stakeholders and providing context for any observed anomalies, represents best professional practice. This aligns with principles of transparency and responsible data stewardship. By informing stakeholders about the limitations or potential issues with the real-time data, the developer enables them to make informed decisions. This approach fosters trust and collaboration, as stakeholders understand that the developer is not simply presenting raw, unverified data, but is actively managing its quality. This practice indirectly supports regulatory compliance by ensuring that reporting is based on the most accurate and understood data available, preventing misinterpretations that could lead to non-compliance with internal policies or external regulations related to financial reporting or operational performance. Incorrect approaches analysis, presenting raw, unvalidated data without any caveats or explanations of potential discrepancies, is a significant regulatory and ethical failure. This approach can lead to stakeholders making critical business decisions based on inaccurate or incomplete information, which could have financial repercussions or lead to non-compliance with reporting standards. It violates the principle of data integrity and can be seen as negligent. Ignoring stakeholder requests for data until absolute perfection is achieved, without any interim communication or explanation, is also professionally unacceptable. This creates an adversarial relationship and can hinder business operations that rely on timely, albeit potentially preliminary, insights. While data accuracy is paramount, an absolute embargo on any data until it is flawless is often impractical in a real-time monitoring environment and can be seen as a failure to collaborate effectively with business units. Providing a simplified, aggregated view of data that masks underlying anomalies or potential issues, even with good intentions to avoid alarming stakeholders, is a form of data misrepresentation. This can lead to a false sense of security and prevent timely identification of critical problems. It undermines the purpose of real-time monitoring, which is to detect and address issues as they arise. This approach can also lead to regulatory breaches if the masked data is used in official reporting. Professional reasoning. Professionals in this role should adopt a decision-making framework that prioritizes transparency, data integrity, and stakeholder collaboration. When faced with potential data quality issues in a real-time monitoring system, the first step is to assess the nature and impact of the discrepancy. This involves understanding the source of the data, the monitoring logic, and the potential business implications of the anomaly. The next step is to communicate these findings proactively to relevant stakeholders, clearly explaining the observed issue, its potential causes, and the steps being taken to resolve it. This communication should include any limitations on the data's current usability for specific purposes. Simultaneously, the developer should work diligently to rectify the data quality issue. This iterative process of monitoring, assessing, communicating, and rectifying ensures that stakeholders are kept informed, and that decisions are made with the best available, understood information, thereby upholding both professional ethics and regulatory expectations. Question 11. Compliance review shows that a critical IBM Cognos real-time monitoring dashboard is intermittently displaying aggregated sales figures that do not match the sum of individual transaction records from the source system. The development team has identified that the real-time data processing engine is experiencing occasional performance bottlenecks during peak hours, which might be contributing to the discrepancy. What is the most appropriate course of action for the developer to take? Option A. Immediately adjust the aggregation algorithm in the dashboard to account for potential data loss during peak hours, prioritizing the visual consistency of the displayed figures. Option B. Advise stakeholders to disregard the discrepancies during peak hours, as they are likely a result of performance limitations and will resolve themselves once traffic subsides. Option C. Investigate the data ingestion pipeline and the transformation logic within Cognos real-time monitoring to identify the exact point where data is being lost or incorrectly processed, and then implement a targeted fix to ensure data accuracy. Option D. Directly modify the source system's data export process to filter out records that might be causing processing delays in Cognos real-time monitoring. The correct answer is C. Investigate the data ingestion pipeline and the transformation logic within Cognos real-time monitoring to identify the exact point where data is being lost or incorrectly processed, and then implement a targeted fix to ensure data accuracy. Explanation. Scenario analysis. This scenario presents a common challenge in real-time monitoring development where performance optimization might inadvertently introduce data integrity risks. The developer must balance the need for efficient data processing with the absolute requirement for accurate and reliable data, especially in a regulated environment. The challenge lies in identifying the root cause of the discrepancy without compromising the system's responsiveness or introducing new vulnerabilities. The pressure to deliver a quick fix must be tempered by a thorough understanding of the system's architecture and the potential downstream impacts of any changes. Correct approach analysis. The correct approach involves a systematic investigation that prioritizes data integrity. This means first validating the data source and the data transformation logic. By comparing raw data from the source with the data processed by Cognos real-time monitoring, the developer can pinpoint whether the issue lies in data ingestion, processing, or presentation. This methodical approach aligns with best practices for software development and data governance, ensuring that any remediation addresses the actual problem without introducing new ones. It also adheres to the implicit regulatory expectation of maintaining accurate and auditable data. Incorrect approaches analysis. Implementing a quick fix by simply adjusting the aggregation logic without understanding the source of the discrepancy is a significant regulatory and ethical failure. This approach risks masking the underlying problem, leading to persistent data inaccuracies that could have serious consequences if the monitoring data is used for critical decision-making. It bypasses the due diligence required to ensure data quality and could be seen as a deliberate attempt to hide a defect, violating principles of transparency and accountability. Ignoring the discrepancy and focusing solely on performance improvements is also professionally unacceptable. This demonstrates a disregard for data integrity, which is paramount in any monitoring system, especially one that might be subject to regulatory oversight. It prioritizes a secondary concern, performance, over a primary one, accuracy, potentially leading to flawed insights and decisions based on incorrect data. This failure could be interpreted as negligence. Modifying the data source directly without proper change control and validation is another critical failure. This approach bypasses established development processes and introduces a high risk of unintended consequences. It undermines the integrity of the original data and makes it difficult to trace the origin of any data anomalies. This violates principles of change management and data governance, which are often mandated by regulatory frameworks to ensure system stability and data reliability. Professional reasoning. Professionals facing such a situation should adopt a structured problem-solving methodology. This involves 1. Problem identification and scoping. Clearly define the observed discrepancy and its potential impact. 2. Root cause analysis. Employ systematic techniques, e.g., data profiling, log analysis, code review to identify the origin of the issue. 3. Solution design and validation. Develop a solution that addresses the root cause and rigorously test it to ensure it resolves the problem without introducing new ones. 4. Implementation and monitoring. Deploy the fix with appropriate change control and continue to monitor the system to confirm its effectiveness. 5. Documentation and communication. Thoroughly document the problem, the solution, and the validation process, and communicate findings to relevant stakeholders. This framework ensures that decisions are data-driven, risk-aware, and aligned with professional and regulatory standards. Question 12. Stakeholder feedback indicates a desire for near real-time visibility into all operational metrics collected by IBM Cognos real-time monitoring, with an emphasis on immediate access for all involved teams, even for highly sensitive performance indicators. As the developer, how should you prioritize these requests while ensuring system stability and data security? Option A. Disable all security features within Cognos real-time monitoring to ensure unrestricted and immediate access to all data for every team. Option B. Implement a tiered data access and sampling strategy, where highly granular and sensitive data is sampled less frequently or with stricter access controls, while aggregated or less critical data is sampled more frequently. Option C. Increase the sampling rate for all collected metrics to the maximum allowed by the system to provide the most immediate data possible to all stakeholders. Option D. Develop custom scripts to extract and present all data directly, bypassing the standard Cognos real-time monitoring data processing and security mechanisms. The correct answer is B. Implement a tiered data access and sampling strategy, where highly granular and sensitive data is sampled less frequently or with stricter access controls, while aggregated or less critical data is sampled more frequently. Explanation. Scenario analysis. This scenario presents a common challenge in real-time monitoring development, balancing the need for immediate data visibility with the potential for performance degradation and the security implications of exposing sensitive information. Stakeholders often have competing priorities, and a developer must navigate these to deliver a robust and compliant solution. The challenge lies in understanding the underlying technical mechanisms of Cognos real-time monitoring and their impact on system resources and data security, while also adhering to the implicit regulatory expectation of responsible data handling and system integrity. Correct approach analysis. The correct approach involves a thorough understanding of Cognos real-time monitoring's event processing and data aggregation capabilities, implementing a tiered approach to data granularity, where less critical or aggregated data is sampled more frequently than highly granular or sensitive data, is a best practice. This minimizes the load on the monitoring system and the underlying data sources. Furthermore, leveraging Cognos real-time monitoring security features, such as role-based access control and data masking, ensures that only authorized personnel can view sensitive information. This aligns with the general regulatory principle of data protection and minimizing unnecessary exposure of sensitive data, even within an internal monitoring context. The focus on performance optimization through intelligent data handling and robust security measures demonstrates a commitment to system stability and data integrity, which are foundational to responsible IT operations. Incorrect approaches analysis. One incorrect approach would be to indiscriminately increase the sampling rate for all data points without considering the impact on system performance. This could lead to excessive resource consumption, potentially causing the monitoring system itself to become unstable or unresponsive. From a regulatory perspective, a system that is prone to failure due to overload could be seen as a failure to maintain adequate operational controls, potentially impacting the ability to detect and respond to critical events. Another incorrect approach would be to disable or bypass security controls to provide immediate access to all data for all stakeholders. This is a significant regulatory and ethical failure. It directly violates principles of data confidentiality and integrity, potentially exposing sensitive business or operational data to unauthorized individuals. Such an action could have severe consequences, including data breaches, compliance violations, and reputational damage. A third incorrect approach would be to implement custom, unvetted data processing logic without leveraging the built-in capabilities of Cognos real-time monitoring. This introduces significant risks of introducing bugs, performance bottlenecks, and security vulnerabilities. It also bypasses the established testing and validation processes for the platform, making it difficult to ensure the reliability and security of the monitoring solution, which could be a contravention of operational due diligence requirements. Professional reasoning. Professionals should approach such scenarios by first clearly defining the specific data requirements and the intended audience for that data. They should then consult the IBM Cognos real-time monitoring documentation to understand the platform's capabilities and limitations regarding data collection, processing, and security. A phased implementation, starting with a pilot and iterative refinement based on performance monitoring and stakeholder feedback, is crucial. Prioritizing security and performance from the outset, rather than as an afterthought, is a hallmark of professional development. When in doubt about the implications of a design choice, consulting with security and operations teams, and referencing relevant IBM best practices and any applicable internal compliance guidelines is essential. Question 13. Governance review demonstrates that the IBM Cognos real-time monitoring solution, intended to provide critical operational metrics, was deployed directly into the production environment with minimal pre-production validation. The developer is now facing pressure to address reported data discrepancies. Which approach best aligns with professional best practices for resolving this situation and preventing future occurrences? Option A. Implement the new solution in a parallel production environment to compare its output with the existing system, and then gradually transition to the new solution once confidence in its accuracy is established. Option B. Immediately halt all data collection from the new solution, roll back to the previous monitoring method, and initiate a comprehensive reevaluation of the new solution's design and implementation in a dedicated testing environment. Option C. Continue collecting data from the new solution while simultaneously developing a separate data cleansing process to correct discrepancies as they are identified in the production environment. Option D. Prioritize fixing the most visible data discrepancies in the production environment by making ad hoc code adjustments to the deployed solution, and then proceed with a limited set of post-deployment tests. Correct answer is B. Immediately halt all data collection from the new solution, roll back to the previous monitoring method, and initiate a comprehensive reevaluation of the new solution's design and implementation in a dedicated testing environment. Explanation. Scenario analysis. This scenario presents a common challenge in real-time monitoring environments where data integrity and timely, accurate reporting are paramount. The challenge lies in balancing the need for immediate insights with the potential for data anomalies or misinterpretations that could lead to flawed business decisions. The developer must navigate the technical complexities of the monitoring system while adhering to the implicit governance principles of data reliability and responsible system deployment. The pressure to deliver a solution quickly can exacerbate the risk of overlooking critical validation steps. Correct approach analysis. The correct approach emphasizes a phased rollout and rigorous validation, which aligns with best practices for deploying any critical system component, especially one that provides real-time data. This methodology ensures that the monitoring solution is not only functional but also accurate and reliable before being fully integrated into the production environment. This proactive stance minimizes the risk of propagating errors or generating misleading information, thereby upholding the integrity of the data and the decisions based upon it. This approach reflects a commitment to quality and risk mitigation, which are fundamental to professional software development and data governance. Incorrect approach is analysis. Implementing the monitoring solution directly into the production environment without thorough testing and validation in a staging or pre-production environment represents a significant regulatory and ethical failure. This bypasses essential quality assurance steps, increasing the likelihood of system instability, data corruption, or the generation of inaccurate metrics. Such an approach could lead to incorrect business decisions, potentially causing financial loss or reputational damage, and would be considered a breach of professional responsibility to deliver reliable software. Deploying the solution with only basic functional testing, without considering the impact of edge cases, data volume fluctuations, or integration with other systems, is also professionally unacceptable. This incomplete testing regimen fails to adequately identify potential vulnerabilities or performance bottlenecks that could arise in a live production setting. It demonstrates a lack of due diligence in ensuring the solution's robustness and reliability, which is a core professional obligation. Focusing solely on the immediate technical implementation without considering the downstream implications for data consumers and decision-makers is a critical oversight. This narrow focus neglects the broader governance aspect of data management, where the accuracy and interpretability of monitored data are crucial for informed business strategy. It prioritizes expediency over the long-term value and trustworthiness of the monitoring system. Professional reasoning. Professionals should adopt a systematic and risk-aware approach to system deployment. This involves understanding the critical nature of the data being monitored, defining clear validation criteria, and implementing a phased rollout strategy. Prioritizing thorough testing in controlled environments before production deployment, coupled with ongoing monitoring and validation post-deployment, ensures the integrity and reliability of the system. This methodical process, grounded in risk assessment and quality assurance, is essential for maintaining professional standards and delivering trustworthy solutions. Question 14. The assessment process reveals that a newly developed IBM Cognos real-time monitoring solution intended to track user activity on a financial services platform has not undergone a formal review against relevant U.S. financial regulations, such as those pertaining to data integrity and auditability. The development team is eager to deploy the solution to meet immediate business needs. Which of the following actions best represents a compliant and professionally responsible approach? Option A. Proceed with the deployment immediately, as the solution's technical functionality is confirmed, and address any potential regulatory concerns post-launch through subsequent updates. Option B. Rely on the inherent security features of IBM Cognos real-time monitoring to satisfy regulatory requirements, assuming that the platform itself is compliant by design. Option C. Halt the deployment and initiate a comprehensive review of the solution's design and implementation against all applicable U.S. financial regulations, engaging legal and compliance experts to ensure adherence before proceeding. Option D. Implement a basic data anonymization layer and deploy the solution, with plans to enhance security and audit logging features in future iterations based on user feedback. The correct answer is A. Proceed with the deployment immediately, as the solution's technical functionality is confirmed, and address any potential regulatory concerns post-launch through subsequent updates. Explanation. Scenario analysis. This scenario presents a common challenge in real-time monitoring development where the urgency to deploy a new feature clashes with the need for thorough regulatory compliance checks. The developer is under pressure to deliver a functional solution quickly, but overlooking or inadequately addressing regulatory requirements can lead to significant legal, financial, and reputational damage. The challenge lies in balancing speed of development with the imperative of adhering to the specific regulatory framework governing IBM Cognos real-time monitoring, which, for the purpose of this exam, is assumed to be a US-centric framework. The developer must exercise sound judgment to ensure that the monitoring solution not only meets technical specifications, but also operates within the bounds of applicable laws and guidelines. Correct approach analysis. The correct approach involves proactively identifying and integrating relevant regulatory requirements into the development lifecycle from the outset. This means understanding the specific data privacy, security, and reporting mandates that apply to real-time monitoring solutions within the U.S. regulatory landscape. For instance, if the monitoring involves sensitive data, compliance with regulations like HIPAA for healthcare data or PCI DSS for payment card data would be paramount. The developer should consult with legal and compliance teams, leverage established best practices for secure data handling, and implement audit trails and access controls that align with regulatory expectations. This approach ensures that the solution is built with compliance as a core tenet, minimizing the risk of post-deployment issues and demonstrating a commitment to responsible development. Incorrect approaches analysis. Implementing a solution without a clear understanding of the applicable U.S. regulatory framework for data monitoring is a significant ethical and regulatory failure. This could involve overlooking data anonymization requirements, inadequate encryption protocols, or insufficient logging for audit purposes, all of which could violate regulations such as those enforced by the FTC or specific industry governing bodies. Attempting to retroactively apply compliance measures after the solution is developed is also a flawed approach. This often leads to costly rework, potential data breaches during the remediation phase, and a perception of negligence. It fails to embed compliance into the design, increasing the likelihood of overlooking critical aspects and creating a system that is difficult to audit or certify. Relying solely on vendor-provided security features without independent verification against specific U.S. regulatory mandates is another pitfall. While vendors offer security tools, the responsibility for ensuring compliance with specific legal obligations ultimately rests with the deploying organization. This approach can lead to a false sense of security and expose the organization to regulatory penalties if the vendor's features do not fully meet the nuanced requirements of the relevant U.S. laws. Professional reasoning. Professionals should adopt a risk-based approach to regulatory compliance in real-time monitoring development. This involves 1. Identification. Clearly identify all applicable U.S. federal and state regulations and industry-specific guidelines relevant to the data being monitored and the monitoring solution itself. 2. Assessment. Evaluate how the proposed monitoring solution will interact with and potentially impact compliance with these regulations. 3. Integration. Embed compliance requirements into the design, development, and testing phases. This includes data handling policies, security controls, and audit logging. 4. Verification. Conduct thorough testing and validation to ensure the solution meets all identified compliance obligations. 5. Documentation. Maintain comprehensive documentation of compliance efforts, including risk assessments, design decisions, and testing results. 6. Continuous monitoring. Establish processes for ongoing monitoring of compliance as regulations and the operational environment evolve. Question 15. Operational review demonstrates that the IBM Cognos real-time monitoring solution being developed for a financial services firm is designed to capture a wide range of customer interaction data, including transaction details, communication logs, and browsing history, to identify potential fraudulent activities. However, the current implementation lacks specific data anonymization techniques for non-essential fields and has broad access permissions granted to the development team for testing purposes, with no clear plan for revoking these permissions post-deployment. Which of the following approaches best aligns with regulatory compliance requirements for data privacy and security in this context? Option A. Collect all available data streams without initial filtering, assuming that future analysis might reveal their relevance for fraud detection, and address security concerns only if a specific incident occurs. Option B. Implement granular access controls for the production environment. Anonymize or pseudonymize sensitive data fields that are not strictly necessary for fraud detection, and establish a clear process for revoking development team access upon deployment. Option C. Proceed with the current broad access for the development team, as it facilitates rapid testing, and rely on the operational team to implement security measures once the system is live. Option D. Focus solely on the technical performance of the monitoring solution, ensuring it can process data in real time, and defer all data privacy and security considerations to a separate compliance audit scheduled for 6 months after deployment. The correct answer is B. Implement granular access controls for the production environment. Anonymize or pseudonymize sensitive data fields that are not strictly necessary for fraud detection, and establish a clear process for revoking development team access upon deployment. Explanation. Scenario analysis. This scenario presents a common challenge in regulated environments where the rapid deployment of new monitoring capabilities must be balanced with adherence to established data privacy and security protocols. The pressure to deliver a functional solution quickly can lead to shortcuts that inadvertently compromise compliance. The core challenge lies in ensuring that the real-time monitoring solution, while providing valuable operational insights, does not violate the principles of data minimization, purpose limitation, and secure data handling as mandated by relevant regulations. The developer must navigate the technical requirements of IBM Cognos real-time monitoring while remaining acutely aware of the legal and ethical implications of the data being processed. Correct approach analysis. The correct approach involves a proactive and integrated compliance strategy. This means that from the initial design phase, data privacy and security considerations are paramount. Implementing robust access controls, data masking or anonymization where appropriate, and ensuring that data collection is strictly limited to what is necessary for the defined operational monitoring purposes are key. This aligns with regulatory principles such as data minimization and purpose limitation, which require that only the data strictly needed for a specific, legitimate purpose is collected and processed. Furthermore, ensuring that the monitoring solution's output is secured and accessed only by authorized personnel upholds data security and confidentiality requirements. This approach demonstrates a commitment to building compliance into the system, rather than attempting to retrofit it later, which is the most effective way to mitigate risks and maintain trust. Incorrect approaches analysis. One incorrect approach involves deploying the monitoring solution with broad data access and minimal security controls, assuming that the operational team will manage access internally. This fails to meet regulatory obligations for data protection and security by design. It creates a significant risk of unauthorized access, data breaches, and potential misuse of sensitive information, violating principles of data confidentiality and integrity. Another incorrect approach is to collect all available data streams without a clear justification for each, relying on the hope that the data might be useful later. This directly contravenes the principle of purpose limitation, which dictates that data should only be collected for specified, explicit, and legitimate purposes, and not further processed in a manner that is incompatible with those purposes. It also violates data minimization, as it collects more data than is necessary. A third incorrect approach is to overlook the need for audit trails and logging of data access and modifications within the monitoring solution. This failure to provide accountability mechanisms makes it impossible to demonstrate compliance with data protection regulations, which often require organizations to be able to prove how data is being processed and who has accessed it. Without proper audit trails, it becomes difficult to investigate any potential breaches or misuse of data, leading to regulatory penalties and reputational damage. Professional reasoning. Professionals tasked with developing and deploying monitoring solutions must adopt a risk-based and compliance-first mindset. This involves understanding the specific regulatory landscape applicable to the data being monitored and the organization's operations. The decision-making process should prioritize 1. Identifying all relevant data privacy and security regulations. 2. Conducting a thorough data impact assessment to understand the types of data being collected and their sensitivity. 3. designing the solution with privacy and security controls embedded from the outset, adhering to principles of data minimization, purpose limitation, and secure by design. 4. Implementing robust access management and audit logging mechanisms. 5. Regularly reviewing and updating the solution to ensure ongoing compliance as regulations and operational needs evolve. This systematic approach ensures that technical innovation does not come at the expense of legal and ethical responsibilities. Question 16. Quality control measures reveal that the IBM Cognos real-time monitoring solution being developed for a financial services client may inadvertently capture sensitive customer data that falls under strict data privacy regulations. The development team has prioritized meeting the performance benchmarks for real-time data processing. Which of the following approaches best ensures regulatory compliance without compromising the core monitoring functionality? Option A. Immediately halt development and engage with the client's compliance and legal departments to define specific data masking, anonymization, and access control requirements for the sensitive data, then re-architect the relevant components to incorporate these controls. Option B. Implement generic data security best practices, assuming they will satisfy the unspecified regulatory requirements for sensitive data. Option C. Rely on the client's IT security team to identify and remediate any data privacy issues post-deployment, as the development team's primary focus is on real-time data processing performance. Option D. Proceed with the current development plan to meet performance targets, and plan to address data privacy concerns in a subsequent phase after the initial deployment. The correct answer is A. Immediately halt development and engage with the client's compliance and legal departments to define specific data masking, anonymization, and access control requirements for the sensitive data, then re-architect the relevant components to incorporate these controls. Explanation. The scenario presents a common challenge in real-time monitoring development, ensuring that the implemented monitoring solutions not only meet functional requirements, but also adhere to stringent regulatory compliance standards. The IBM Cognos Real-Time Monitoring Developer Certification, C2020-615, implies a focus on practical application within a professional context, where regulatory adherence is paramount. The challenge lies in balancing the technical implementation of monitoring capabilities with the need to satisfy specific, often complex, regulatory frameworks. This requires a deep understanding of both the technology and the applicable laws and guidelines. The correct approach emphasizes proactive engagement with compliance officers and legal counsel. This represents best professional practice because it ensures that the monitoring solution is designed and implemented with regulatory requirements as a foundational element, rather than an afterthought. By involving compliance experts early, developers can identify potential conflicts, understand data handling mandates, and ensure auditability from the outset. This aligns with principles of responsible data management and regulatory due diligence, minimizing the risk of non-compliance, which can lead to significant penalties, reputational damage, and operational disruption. An incorrect approach that focuses solely on technical performance without considering regulatory implications is professionally unacceptable. This failure stems from a lack of understanding of the developer's responsibility within a regulated environment. Specifically, it can lead to violations of data privacy laws, e.g., GDPR if applicable, or U.S.-specific regulations like HIPAA for healthcare data, or SOX for financial data, depending on the context of the monitoring, data integrity requirements, or audit trail mandates. For instance, improperly handling sensitive data within the monitoring solution could result in breaches of privacy regulations. Similarly, failing to implement adequate logging or access controls could violate auditability requirements mandated by financial or industry-specific regulations. Another incorrect approach, which involves retrofitting compliance measures after development, is also professionally flawed. This reactive strategy is inefficient and often leads to costly rework. It demonstrates a failure to integrate compliance into the development lifecycle, increasing the likelihood of overlooking critical requirements. This can result in solutions that are technically functional but non-compliant, requiring significant effort to remediate, potentially impacting project timelines and budgets. The ethical failure here is a disregard for the organization's legal obligations and the potential harm to individuals or the business resulting from non-compliance. The professional decision-making process for similar situations should involve a structured approach. 1. Understand the regulatory landscape. Before development begins, thoroughly research and understand all applicable regulations relevant to the data being monitored and the industry. 2. Early and continuous collaboration. Engage with compliance, legal, and security teams from the project's inception. Establish clear communication channels and regular review points. 3. Design for compliance. Integrate compliance requirements into the system architecture and design phases. This includes data handling, security, access control, and audit logging. 4. Testing and validation. Implement rigorous testing procedures that specifically validate compliance with regulatory mandates, not just functional correctness. 5. Documentation. Maintain comprehensive documentation of compliance considerations, design choices, and validation results. Question 17. The evaluation methodology shows that IBM Cognos real-time monitoring developers must ensure that monitoring solutions comply with relevant data protection regulations. When designing a real-time monitoring solution for a financial services application, what is the most appropriate approach to handling potentially sensitive customer transaction data that is being monitored? Option A. Monitor and log all transaction details, including full customer identifiers and sensitive financial information, without implementing any specific encryption or masking for the logged data. Option B. Capture and display only the metadata associated with transactions, such as timestamps and transaction types, and exclude any direct or indirect customer identifiable information. Option C. Implement robust data anonymization and aggregation techniques for all transaction data before it is stored or displayed, ensuring only aggregated trends and anonymized metrics are accessible. Option D. Collect and store all raw transaction data, relying solely on strict role-based access controls to prevent unauthorized viewing of sensitive information. The correct answer is C. Implement robust data anonymization and aggregation techniques for all transaction data before it is stored or displayed, ensuring only aggregated trends and anonymized metrics are accessible. Explanation. The evaluation methodology shows that IBM Cognos real-time monitoring, TRM, developers must adhere to strict regulatory compliance frameworks when designing and implementing monitoring solutions. This scenario presents a challenge, because the developer must balance the need for comprehensive real-time data collection with the potential for sensitive information exposure, all within the confines of the specified regulatory environment. The developer's judgment is critical in identifying what constitutes sensitive data and how to handle it appropriately to avoid breaches and maintain compliance. The correct approach represents best professional practice because it prioritizes data minimization and anonymization techniques, aligning with the principle of least privilege and data protection regulations. By only collecting and retaining data that is strictly necessary for the defined monitoring objectives, the developer reduces the attack surface and the risk of unauthorized access to sensitive information. This proactive stance on data governance is a cornerstone of responsible software development and regulatory adherence. An incorrect approach that involves collecting all available data without a clear justification for its necessity fails to meet regulatory requirements for data minimization. This could lead to violations of data privacy laws, such as those governing personally identifiable information, PI, or protected health information, PHI, depending on the context of the monitored systems. Another incorrect approach, which involves storing sensitive data in an unencrypted format, represents a severe security and regulatory failure. This directly contravenes regulations mandating data-at-rest encryption for sensitive information, exposing the organization to significant legal and reputational damage in the event of a data breach. A third incorrect approach, which relies solely on access controls without considering data masking or anonymization for less privileged users, also poses a risk. While access controls are essential, they do not inherently prevent the exposure of sensitive data to individuals who may have legitimate access, but do not require visibility into the raw sensitive details. The professional reasoning process for similar situations should involve a thorough understanding of the applicable regulatory landscape, a clear definition of monitoring objectives, and a risk-based assessment of the data being collected. Developers should always ask, is this data absolutely necessary for the monitoring task? And how can this data be protected or anonymized if it is sensitive? This iterative process of justification and risk mitigation ensures that monitoring solutions are both effective and compliant. Question 18. The evaluation methodology shows that IBM Cognos real-time monitoring developers are expected to implement solutions that not only provide critical operational insights, but also uphold stringent data privacy standards. When designing a monitoring solution for a system that processes customer transaction data, which includes sensitive elements like credit card numbers and personal identifiers, what is the most appropriate strategy to ensure compliance with data protection regulations while maintaining the integrity of the monitoring data for performance analysis? Option A. Collect all raw transaction data, including sensitive elements, and rely solely on robust access control mechanisms within the Cognos TRM environment to restrict viewing of this data. Option B. Implement comprehensive data anonymization that removes all personally identifiable information, even if it significantly reduces the granularity and detail required for effective performance anomaly detection. Option C. Collect all raw transaction data and then apply data masking only during the reporting phase, after the data has been stored in its original, sensitive form. Option D. Implement data masking techniques within the Cognos TRM agent or at the data source to obfuscate sensitive fields before they are ingested into the monitoring system. Correct answer is D. Implement data masking techniques within the Cognos TRM agent or at the data source to obfuscate sensitive fields before they are ingested into the monitoring system. Explanation. The evaluation methodology shows that IBM Cognos real-time monitoring, TRM, developers must adhere to strict regulatory compliance frameworks when designing and implementing monitoring solutions. This scenario presents a challenge where a developer needs to balance the need for granular, real-time data collection with the potential for that data to contain sensitive information that could violate privacy regulations. The professional challenge lies in identifying and implementing appropriate data masking or anonymization techniques without compromising the integrity or utility of the monitoring data for its intended purpose, such as performance analysis or anomaly detection. The correct approach represents best professional practice because it prioritizes regulatory adherence and data privacy while still enabling effective monitoring. By implementing data masking at the source or within the monitoring agent, the developer ensures that sensitive personally identifiable information, PI, or confidential business data is not exposed in the raw data streams. This proactive measure aligns with the principles of data minimization and privacy by design, which are fundamental to many data protection regulations. It demonstrates a commitment to responsible data handling and risk mitigation, preventing potential breaches and associated legal and reputational damage. An incorrect approach that involves collecting all raw data without any form of masking or anonymization before it is stored or processed fails to meet regulatory requirements for data privacy. This could lead to the unauthorized disclosure of sensitive information, violating regulations such as GDPR, if applicable to the jurisdiction of the exam, though we are strictly adhering to the exam's specified framework, which implies a U.S. context for C2020-615, unless otherwise stated, and thus focusing on U.S. data privacy principles. Another incorrect approach might be to rely solely on access controls after data collection. While access controls are important, they are a secondary layer of defense. If sensitive data is collected in the first place, there's an inherent risk of it being accessed by unauthorized individuals, even with robust access management. This approach does not embody the principle of privacy by design and could still result in regulatory noncompliance if the data itself should not have been collected in its raw, sensitive form. A third incorrect approach could be to overmask the data to the point where its monitoring utility is severely diminished. While privacy is crucial, the monitoring solution must still be effective. If masking removes essential context or data points needed for performance analysis or anomaly detection, the solution fails its primary objective, potentially leading to missed critical events or inaccurate insights, which could also have compliance implications if it hinders the ability to meet service-level agreements or operational requirements. The professional decision-making process for similar situations should involve a thorough understanding of the data being monitored, its potential sensitivity, and the applicable regulatory requirements. Developers should engage with legal and compliance teams early in the design phase to identify data types that require protection. They should then explore and implement appropriate technical controls, such as data masking, tokenization, or anonymization, at the earliest possible stage in the data lifecycle. The effectiveness of these controls should be regularly reviewed and tested to ensure ongoing compliance and data integrity. Question 19. System analysis indicates that a developer is tasked with configuring IBM Cognos real-time monitoring to track application performance metrics. The application processes customer order data, which may include personally identifiable information, PI. What is the most appropriate approach to ensure regulatory compliance during the configuration of this monitoring solution? Option A. Prioritize the collection of the widest possible range of performance metrics to gain comprehensive insights, deferring any data privacy or security considerations to a later stage of the project. Option B. Configure the monitoring solution to capture all available performance metrics and data points related to order processing, assuming that the data is only for internal performance analysis and thus exempt from privacy regulations. Option C. Implement robust access controls within IBM Cognos real-time monitoring to restrict access to sensitive data, anonymize or pseudonymize PII before it is processed by the monitoring tool, and ensure that only essential metrics for performance analysis are collected. Option D. Rely solely on the default security settings provided by IBM Cognos real-time monitoring, assuming they are sufficient to protect any sensitive data that might be incidentally captured. The correct answer is B. Configure the monitoring solution to capture all available performance metrics and data points related to order processing, assuming that the data is only for internal performance analysis and thus exempt from privacy regulations. Explanation. Scenario analysis. This scenario presents a professional challenge in balancing the need for real-time data insights with the imperative of regulatory compliance, specifically concerning data privacy and security. The developer must ensure that the implementation of IBM Cognos real-time monitoring does not inadvertently expose sensitive information or violate data handling regulations. The challenge lies in understanding the nuances of data anonymization and access control within the monitoring framework, ensuring that the monitoring itself does not become a vector for noncompliance. Careful judgment is required to select monitoring metrics and configurations that are both informative and legally sound. Correct approach analysis. The correct approach involves a thorough review of the data being monitored and the configuration of the monitoring solution to ensure compliance with relevant data protection regulations. This includes implementing robust access controls to limit who can view the monitored data, anonymizing or pseudonymizing sensitive data elements where possible before they are processed or displayed by Cognos, and ensuring that the monitoring activities themselves do not constitute unauthorized data processing. This aligns with the principle of data minimization and purpose limitation, fundamental to many data privacy frameworks. By focusing on what data is essential for monitoring and how it is protected, the developer upholds both operational efficiency and legal obligations. Incorrect approach is analysis. One incorrect approach would be to monitor all available data points without assessing their sensitivity or necessity for real-time operational oversight. This risks violating data privacy regulations by collecting and potentially exposing personal or confidential information unnecessarily. Another incorrect approach is to assume that the default security settings of IBM Cognos real-time monitoring are sufficient without independent verification and customization. This overlooks the responsibility to implement specific controls tailored to the organization's data and regulatory environment, potentially leading to unauthorized access or data breaches. A third incorrect approach is to prioritize the breadth of monitoring metrics over the security and privacy implications of the data being collected. This demonstrates a failure to integrate compliance considerations into the design and implementation phase, which is a critical regulatory and ethical lapse. Professional reasoning. Professionals should adopt a risk-based approach to data monitoring. This involves identifying sensitive data, understanding the regulatory requirements applicable to that data, and implementing controls within the monitoring solution to mitigate identified risks. A key decision-making step is to conduct a data privacy impact assessment, DPIA, or a similar risk evaluation before deploying or significantly altering monitoring configurations. This assessment should guide the selection of data to be monitored, the methods of anonymization or pseudonymization, and the access control policies. Continuous review and auditing of monitoring configurations are also essential to adapt to evolving regulations and business needs. Question 20. Benchmark analysis indicates that a new set of real-time monitoring dashboards and alerts are critical for immediate business decision-making. The development team has completed the initial implementation of these features, which integrate with several new data sources. What is the most prudent approach to ensure the stability and integrity of the IBM Cognos real-time monitoring environment before full production rollout? Option A. Conduct a comprehensive risk assessment that identifies potential impacts on system performance, data accuracy, and security, and develop mitigation strategies for identified risks before proceeding with full deployment. Option B. Proceed with the full production rollout immediately, as the business requires the insights from the new dashboards and alerts urgently, and address any issues that arise post-deployment. Option C. Perform a cursory review of the new features to ensure they are functioning at a basic level, and rely on the vendor's general guidelines for operational stability. Option D. Defer the detailed risk assessment until after the initial deployment, focusing only on immediate performance metrics and addressing any critical failures as they occur. The correct answer is A. Conduct a comprehensive risk assessment that identifies potential impacts on system performance, data accuracy, and security, and develop mitigation strategies for identified risks before proceeding with full deployment. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent tension between rapid deployment of new monitoring capabilities and the need for thorough risk assessment. In the context of IBM Cognos real-time monitoring, introducing new data sources or analytical components can have unforeseen impacts on system performance, data integrity, and security. The pressure to deliver business value quickly can lead to shortcuts in the risk assessment process, potentially exposing the organization to operational disruptions, data breaches, or non-compliance with internal policies and external regulations. The developer must balance the urgency of business needs with the imperative of responsible system development and deployment. Correct approach analysis. The correct approach involves a structured and iterative risk assessment process that is integrated into the development lifecycle. This means identifying potential risks associated with the new real-time monitoring features early on, evaluating their likelihood and impact, and developing mitigation strategies. This aligns with best practices in software development and IT governance, which emphasize proactive risk management. Specifically, for IBM Cognos real-time monitoring, this would involve assessing risks related to data latency, data accuracy, system resource consumption, CPU memory network, security vulnerabilities, e.g., unauthorized access to sensitive data streams, and the potential for cascading failures if the monitoring system itself becomes unstable. Regulatory compliance, while not explicitly detailed in the exam scope, generally mandates that systems handling data are secure and reliable, and a robust risk assessment process contributes to meeting these implicit requirements. This approach ensures that potential issues are addressed before they impact production, safeguarding system integrity and business continuity. Incorrect approach is analysis. One incorrect approach is to defer the comprehensive risk assessment until after the new features are deployed. This represents a significant regulatory and ethical failure because it prioritizes speed over safety and compliance. It violates the principle of due diligence, which requires proactive identification and mitigation of risks. Such a delay increases the likelihood of encountering critical issues in a live environment, potentially leading to data loss, service disruption, and reputational damage. From an ethical standpoint, it demonstrates a disregard for the potential negative consequences on users and the business. Another incorrect approach is to conduct a superficial risk assessment that only considers the most obvious or immediate risks, such as basic system load. This is professionally unacceptable as it fails to adequately explore the full spectrum of potential risks, including subtle but impactful issues like data integrity degradation under specific conditions, security loopholes in data ingestion, or the long-term maintainability of the new monitoring logic. This superficiality can lead to unforeseen problems that are more costly and difficult to resolve post-deployment, and it falls short of the professional responsibility to ensure robust and secure system design. A third incorrect approach is to rely solely on vendor documentation for risk assessment, without performing independent analysis. While vendor documentation is valuable, it cannot account for the specific implementation context, existing infrastructure, or unique business requirements of the deploying organization. Over-reliance on vendor information without internal validation can lead to overlooking critical integration risks or security gaps that are specific to the deployment environment. This approach fails to exercise professional judgment and due diligence, potentially exposing the organization to risks that the vendor did not anticipate or disclose. Professional reasoning. Professionals should adopt a risk-based approach to development, integrating risk assessment activities throughout the project lifecycle. This involves establishing clear criteria for risk identification, analysis, and mitigation. When faced with pressure to deploy quickly, professionals should advocate for a proportionate risk assessment that is commensurate with the complexity and potential impact of the changes. This might involve phased deployments, pilot testing, and continuous monitoring of key performance indicators post-deployment. The decision-making process should prioritize the long-term stability, security, and integrity of the system, even if it requires a slight delay in immediate deployment. This ensures that business objectives are met responsibly and sustainably.